Today we are covering C++ closures, a concept that's essential in real projects, and I'll show you why it matters. Now let's consider a real-world scenario where we need a function to access its own scope, even when it's called outside of that scope. This is a common issue in programming, and that's where closures come in. Watch what happens here. We have a function that needs to remember its birthplace, so to speak. So, we need a way for a function to access its own scope, and that's exactly what closures provide. Now, let me show you an example of how this problem arises in code. A closure is essentially a function that has access to its own scope, and the scope of its outer functions. Here's where most people get confused, but think of it like a house where you have access to your own room and the rooms of your neighbors. Now, let me explain it in simpler terms. A closure is a function that remembers its birth, so it can access the variables of its parent scope. So, a simple definition would be, a closure is a function that has access to its own scope and the scope of its outer functions. Now let's walk through a simple example of a closure in C++. So, first we have a function called outer, and inside outer, we have a function called inner. And here's the key part, inner has access to the scope of outer, so it can use the variables of outer. So, we have int x is equal to 10, then we define our outer function, and inside outer, we define our inner function, and inner returns x. And this last line, we call outer, and it returns inner, which has access to the scope of outer. Let's consider a real-world example of using closures in a project. So, we have a class called calculator, and inside calculator, we have a function called add, which returns another function that adds a certain number to its input. Now, let me show you how this works. We have a class calculator, and inside calculator, we have a function add, which returns a lambda function that adds x to its input. And here's how we use it. We create a calculator object, and we call add on it, and it returns a function that adds 10 to its input. So, we can use this function to add 10 to any number. Here's where most people get confused. When using closures, we need to be careful about variable capture. Now, let me show you an example of what not to do. If we capture a variable by reference and then the variable goes out of scope, we'll have undefined behavior. So, watch what happens here. We have a function that returns a lambda function that captures x by reference, and then we call this function, and it returns the lambda function, but x has already gone out of scope, so we'll have undefined behavior. Did you notice that? Now, let me show you the fix. We need to capture x by value, not by reference. Now that you know about closures, try using them in your next project, and don't forget to subscribe to Akshay for more programming tutorials.